The electromagnetic spectrum.
Introducing light.
The sun, our star, has been providing light to the world longer than humans have been around.
The light fascinates us from an early age.
Light is one of the greatest mysteries of science.
Light behaves as a particle called a photon.
Light also behaves as waves.
Light behaving as a particle.
And a wave is one of the great mysteries in modern physics.
The term electromagnetic spectrum refers to the range of wavelengths that photons can travel at. The light we see is only a small part.
The longest wavelengths in the spectrum are radio waves.
Radio wavelengths can be as long as several kilometers and as short as 30 centimeters.
Go ahead.
The wavelengths of microwaves and radar can vary between 30 centimeters to as small as 0.3 centimeters.
Long microwaves are used to heat food. Food heats as the water molecules in the food vibrate extremely fast.
Very short radar waves can detect matter in the atmosphere, from water vapor to aircraft.
The infrared wavelengths are very small into the microscopic range.
Special cameras can detect infrared light.
Thermal imaging has many practical uses.
Thermal images provide a clear difference between hot and cold temperatures.
After infrared comes visible light, the portion our eyes are familiar with.
What we see as white light is actually a mixture of all the colors.
The longest wavelength we see is red light, the shortest is violet light. The sun also produces ultraviolet light. Ultraviolet wavelengths measure in the nanoscale.
Ultraviolet light is what causes skin damage.
Some insects see in ultraviolet.
This is the same flower when you viewed in ultraviolet light.
The longest ultraviolet rays create black light.
Beyond the ultraviolet is the X-ray portion. As the wavelengths decrease in length, they increase in energy.
X-rays are powerful enough to pass through soft tissues, but reflect off dense tissue. This allows us to see that this hand is okay.
And this hand is not.
Gamma rays are the shortest wavelengths in the spectrum, therefore they are also the highest energy. The waves measure in the nanoscale.
Gamma ray bursts are created when stars explode.
Radioactive decay creates gamma rays used to fight cancer.
The range in wavelength in the electromagnetic spectrum varies between the atomic scale and several kilometers.
In summary, the electromagnetic spectrum consists of all wavelengths from very long radio waves to nanoscale gamma rays.
Thanks, Matt.